this video on atoms, elements and compounds. This is the first lesson that I'm going to talk about in the second unit within the Key Stage 3 curriculum, which is lab skills and an introduction to chemistry. Now I've not made any videos on lab skills for two reasons. One, I'm not in a lab, I'm at home, I don't have any equipment with me to do any modelling. So that would be quite difficult. And two, perhaps more importantly, those lessons on things like measuring temperature, measuring volume, measuring mass, and so on, they're things that most science teachers are pretty good at doing already. So you don't really need me to tell you how to show students how to do that stuff. Where I think it might be useful is in some of these lessons on the chemistry side of it, and especially the kind of theoretical point of view. So that's why I've started at this lesson. And I think through this unit, there's two really important concepts that we need to embed in students' minds. One concept that we need to get them thinking in terms of is this idea of elements and the relationship between elements and atoms. So this is the kind of Lego brick type picture of the universe, where what we need by the end of this unit is for them to start having a sense that everything that's out there in the world actually boils down to these, however many there are, 118 elements, and the fact that atoms of different elements are distinct. There is a difference between hydrogen atoms, oxygen atoms, carbon atoms, whatever. So that's one really, really key idea. The second one, which is going to start to come out in this unit, but really the second concept is the focus of the second chemistry unit, which comes in year 8 on kind of chemical reactions, displacement, acids and alkalis, and so on. The second key idea is conservation of mass, and this idea that any chemical reaction, we start with a certain number of particles or atoms, and we end with the same number of particles or atoms, just rearranged. That's the second key idea. And what I want to do in this lesson, because this is really the first lesson introducing this whole subject of chemistry, what I want to do in this lesson is introduce those two core concepts. Now, I think it's quite helpful to start with the picture of the world that we had before chemistry was an established discipline, and we've covered this already in the first unit in particles and energy, which was unit 1. But I think it's worth returning to just so students are really, really clear what we mean by elements. So I like to start with this kind of Aristotelian picture of the universe as Aristotle and the ancient Greeks saw it, which is of these 4 elements. So we've got one element down here, which is earth. And remember, the ancient Greeks thought everything in the universe was made up of one of these 4 elements, and the elements that dominated affected the properties of different materials. So we've got earth here, that's right down in the middle. That's the kind of heaviest element, like this. Now there's this idea that, well, the earth has got seas around it, so the next layer down is water. So I'll do a W in here for water. This is another of our 4 elements. Then there's this layer of air around the outside, like this. We've got a layer of air, so I'll label that with an A. And then somewhere up here we've got the final element, which is the lightest element, the one that sits above the others, and that's fire. Now, we don't need to go into too much detail here. We could talk about the cosmos as well. So this is this kind of unchanging layer around the outside where the stars are and so on. But this is how the ancient Greeks imagined the universe around them. This is what they imagined it to look like. Now, I like to introduce it here because this is a really clear change in thinking that happened when we had the chemical revolution. And I think the two that I like to focus on are air and water, because this is intuitive to students. They see air around them, or they don't see air around them, but they can feel air around them all the time. And water, it's one of the most common materials they'll ever come up with. It seems so fundamental to human existence. We breathe air in and out, we drink water, so on and so forth. It makes sense to think of these as elements, the most basic substances that we can imagine. And actually, this is why I think it's a good example to focus on these two, because if we show that actually one of these is a mixture and one of these is a compound, we can really start to change the way students are thinking about the world. So I start with air, and I might just do something like this and say, well, actually, what was discovered in about the 1700s is that air wasn't an element. Actually, there were different airs, and I might zoom in on here and show some of these different airs. Now, nowadays, we think about this in terms of particles, and we have the names of the elements like nitrogen, oxygen, carbon dioxide, a bit of argon, and so on. At the time, we didn't have those names. So what I might do here is say, well, what scientists discovered was that actually the air around us is made up of what they call different airs. So the bulk of the air was what they call phlogisticated air. Now, I might not tell that to students. You might just want to go straight to the modern name, which is nitrogen. So it's really up to you. I'm going to call it nitrogen, just to make things simpler here. So what they found was that about 80% of the air around us was this gas called nitrogen, which at the time was called dephlogisticated air. Then there's this other gas, which is all mixed in, and that's about 20% of the air, roughly, which is oxygen. So already we found that one of the things that the ancient Greeks thought was an element, was one of the most basic substances imaginable, actually was just a mixture of two different elements, one element being nitrogen, one element being oxygen. So that's a really early introduction to this idea of elements for our students. On mixtures, by the way, usually what I always used to teach this with mixtures as part of this lesson, but actually if we're thinking about how to break down this knowledge in a way that helps students build those concepts, actually the fundamental distinction that they need to consider first is elements and compounds. Only later, when they're starting to think about chemical reactions and they need to make sure that their reactants are pure, do they really need to start thinking about mixtures. So that's why that is actually parked until later in the scheme. I wouldn't talk about mixtures for now. Do that later, because that comes with a whole separate thing, then with all your distillation and chromatography and so on. So anyway, we've got a mixture of airs. And what I want to show students here is that actually this air that we thought was an element is not an element. This was the first thing that was discovered. Actually, there are different gases that make up the air that we breathe in. So then I want to tell them a little story. Okay, this was about air. Then I want to tell them about some experiments that a scientist called Henry Cavendish did, again, in the 1700s. So what Henry Cavendish did was this. He took a box. Let's call it a glass box, for the sake of argument, although actually I'm not sure you'd want to do the experiment we're going to do in a glass box, because we're going to make a big explosion. And if you want to find videos of this, I'm going to talk about burning hydrogen to the students, feel free to show them the video. But I think it's worth showing them what happened. And what Henry Cavendish did was he filled this with two airs. Now at the time he called those inflammable air and dephlogisticated air. I'm going to give them their modern names, which is hydrogen. That used to be called inflammable air, hydrogen, and oxygen gas. So maybe I'll do this like this. Now again, these would all be completely mixed, so if this diagram is misleading, you might want to draw it differently. But I just want to show students that we've got two gases present in our box. Okay. So what Henry Cavendish did was he mixed the hydrogen and the oxygen like that in a box, and then somehow he managed to pass a flame into it. So I'm just going to draw a match or something like that. I'm going to draw a little flame like that. And again, it might be worth showing them a video here. This diagram is really just to illustrate what's going on when we see this. But what you want students to realise is that if you were to do this, you were to mix hydrogen and oxygen, and then you were to apply some sort of flame or spark, what you would get is a huge explosion. So I'm going to draw a big explosion like this. And I might write bang in here like that, just to give it that kind of Roy Lichtenstein cartoonish quality that Year 7 students love. I might put some kind of blast waves like this as well. So I've got this big explosion, and it's a really exciting one when hydrogen and oxygen react. But what happens next? That's what we're interested in as chemists. What happens next? What actually is going on here? if we take our box and if we imagine it's a glass box that we can see through, well, yeah, I wouldn't want to do this experiment in a glass box, but hopefully you get the idea. Now what we're going to see here is actually what Cavendish found. He kind of got a little puddle of water and little droplets of water on the side of the box like this. So I'll label this as water. And you can tell them some details here, because at the time scientists weren't too worried about health and safety. And Henry Cavendish was wondering what this liquid was, so he literally took it and tasted it with his tongue, and he said, well, it doesn't seem acidic, just seems no smell, there's no taste, just seems like ordinary water. And scientists, they really struggled to explain what was going on here, because okay, we've mixed two different gases, two different substances of some sort. They've reacted, clearly, we can tell they've reacted because there's been an explosion. Again, these are ideas we'll come back to later, but we want to give them the big picture first before we zoom in. Something's clearly happened, but we've ended up with water, which we thought was one of the basic 4 elements. Well, what we want to show students is that actually this experiment shows that water cannot be an element. Actually, there must be other things that make up water. And we can show them here, and again, we'll practice this more later, but we want to give them the whole picture. We want to introduce these concepts, that we can represent what's gone on here in the following form. And I've made a spelling mistake, so let's start again. We can represent it with a word equation. So what we write is something like this: hydrogen plus oxygen. Draw an arrow to show a chemical reaction's taking place, and we get water. Now, what I want to emphasize here is that instead of water being an element, as the ancient Greeks thought, actually that means water must be what's called a compound. And actually these two, hydrogen and oxygen, these gases that we're reacting, these two are the simplest types of substances. These are what we call elements. So I'm going to label these like this. These two are elements. Water is not an element, it's what we call a compound. And this is really important language that I'm introducing my students to. So this is all very macro, and I've represented this with a with an equation. The last thing that I want to do, and again, remember this lesson is to introduce all of the ideas that we're going to cover for the rest of our kind of chemistry career. What I want to do is show them then this new picture of what was going on that we're going to keep coming back to again and again and again and again throughout our chemistry career. And that's the picture that was suggested by Dalton and then refined by Avogadro and so on, which looks something like this. And I think I would draw the correct equation here, or the correct diagram, what's happening at a micro level. So I'm going to draw these diatomic molecules. Again, at this stage, I'm not going to call them diatomic molecules. I just want to give students a picture. And I want to tell them that actually we're going to represent these atoms, which all matter is made up of, as these little circles like this. So I'm going to draw something like this. And I'm going to say, well, what Dalton and Avogadro and others thought was that actually what must be happening here, I'll just focus to make sure that's clear. What must be happening here is that this hydrogen gas and oxygen gas that we had up here must be made of these tiny little atoms. And what happens when there's this big explosion is that these atoms kind of rearrange themselves. So one oxygen goes to there, let's say, and one oxygen goes to there. And what we end up with then, instead of our two H's and two O's bonded together, what we have is something like this. Mickey Mouse molecule like this. And then I can show them. And again, I'm not too worried about relative size and so on at this stage, because all I'm really doing is showing them the difference between an element and a compound. So I get something like this. One of those might be obscured by my camera, but anyway, hopefully you can see that. And then the final thing that I'm going to do when I'm explaining this is then introduce our kind of much more modern definition of elements and compounds, which is as follows. And you might want to just tell the students this because they're going to answer questions on this later. If you want to give that extra level of support, you could write it down as well. But I might draw students' attention to the fact that what makes hydrogen an element is that all of the atoms are of the same type. likewise for oxygen. So I might draw an arrow like this and label this and say we've got the same type of atoms here, which is why we call hydrogen and oxygen elements, because they're made up of the same type of atoms. This would be a compound because each molecule, and again, we might not want to go into that language right now, but you might say each kind of unit or something like that, that's made up of different atoms or different types of atom. I'll just put different atoms for now, chemically combined. I'll write that here like this. And that's all we want to focus on in this lesson, because there's some huge ideas here. And just to recap the big ideas that we've introduced that we're going to keep coming back to throughout this unit. So we've used a concrete example to begin with, but really what we're focused on here is the relationship between elements and the fact that different elements are made up of different types of atom. Also, we've just given students an initial picture of conservation of mass, which is the most important concept really in chemistry at school level. This idea that if we start with these 6 particles, we've got to end with these 6 particles, just rearranged. And again, I stress, I've introduced a lot of stuff here. There's lots and lots of big ideas. The purpose for doing that, it's not so that they'll understand it perfectly by the end of one lesson. It's so that we've given them a picture that we can keep coming back to reinforce these much broader points throughout their learning of chemistry in school. So once you've drawn that, then there's lots and lots of questions in the slides that you can get students thinking about, and they should be able to identify the elements versus the compounds and so on. And then some questions to get them thinking about atoms, elements, and compounds. In the next lesson, we'll look at elements in a bit more detail, and we'll think about how they're represented in the periodic table. Thank you.